In this video, we're going to build this application here, which is a Descript clone. So on the right hand side, you have a video that you upload, and on the left hand side, you have the transcription for that video. You have the playback controls here, and then you have the audio waveform in the bottom so that you can seek to different parts of the video and resume playing from there. We'll continue on from the last video where what we had was the mock transcription on the left. This is just some static text that we've loaded in place of the transcription. And in this video, we're going to work on implementing a speech-to-text model called WhisperX in order to get precise word level timestamps. There were a lot of issues that I faced while building out this application while I was trying to figure out how to prompt cursor, but hopefully you won't run into the same issues. I'll make sure to write the prompts with as much detail as possible so that you can use the same prompts to get to the point where I ended. I'll edit out the parts where I was having trouble prompting cursor just because this video is already pretty long. But if you'd like to see the full version of this video and how I was able to troubleshoot the errors that I was getting from cursor and the code that it was generating, then please let me know in the comments and I can upload the full video with all of my troubleshooting in there as well. In the meantime, try to just follow along with the prompts that I've provided. Make sure that you read through any of the code that cursor generates and libraries that it installs for you, and make sure that it matches the versions that I'm using. And hopefully with all that, you shouldn't have so many issues like I faced. All right, let's get started. So I was originally gonna make this video about this detect silence regions button here, but as I thought about it, it didn't make sense to do it this way. So what this button does is you can set a duration for the silences that you want it to detect. So here it's in seconds. So this is almost a second. So it's going to find any regions that are at least 800 milliseconds long and fall below this volume threshold. So if I click detect silences, you can see that it found these regions here. These are at least 800 milliseconds long and they're under 300 or 30 decibels. And the reason I decided not to do it this way is because the way Descript does it is through the transcript. It's based on the words that are said instead of the audio amplitude. Because for example, right here, it looks like there's some noise. I can actually skip to it and listen. Okay, so when I listened, it wasn't actually me speaking, it was just some background noise. But you can see how, like, for example, right here, it does look like I'm saying a word and I'm trailing off as I'm speaking, and the amplitude falls under this value and then it gets cut off, right? And I can just adjust it so that it doesn't pick up, so I can increase the threshold so that it doesn't pick up anything. It's not as sensitive. And I can do detect regions, and then it finds fewer regions because all these other ones are louder than this value, right? But really what I want to do is remove the regions in between words. So say for example, this little segment right here, there's some noise happening there, and it could be that it's some background noise like a car engine revving or something loud in the background, or maybe you're speaking and you're clearing your throat. Then that region wouldn't get deleted, but you would want it to get deleted because it's not important for the content of the video. And so that's why this technique didn't really work. I added these data points here to show where the highest volumes are, so that way I could play around with this threshold value and like get an understanding of what these decibel values mean. But you can see at the top 3 peaks, which is the loudest part, is all happening at 41 seconds. That's roughly this part right here. You can see it looks like it is the loudest, the highest amplitude. And the lowest 3 peaks are, 2 of them are at 39 seconds, which is like probably right here. If I seek the video, I can see, yeah, that's roughly 39. So yeah, this would be like the lowest 3 points, I mean, compared to everything else, right? But the point of this data is really to just demonstrate what these values correspond to. That way you know how to adjust these decibels according to the numbers that you see here. I wouldn't want to set my threshold above this number here, because then it would just detect everything as silence. So if I do that, then the whole region is silent, right? Because that's threshold is not exceeded. So this implementation has lots of flaws, and I didn't record the video for this because I realized this wasn't going to be a good solution. But if you wanted to see how I prompted it, here's the prompt. Basically, I'm just telling it that I've loaded a file, an audio file, and the audio waveform is displayed. It has several silent regions. Please write out some code to detect those silent regions exceeding a certain number of seconds in the audio waveform. That's this right here. Obviously, if I wanted to, let me refresh. If I wanted to make the duration longer, so I wanted to only detect when maybe it's like 5 seconds long of silence, right? Then in this audio, there wouldn't be any of that because this audio is only 55 seconds. And anyways, there's no silent regions that are longer than 5 seconds. And I just tell it that the default threshold is 800 milliseconds, and it should be configurable in the playback controls UI. And then once it does find those silent regions, add them to the trim history. Remember, the trim history is the edit decision list that I create when I'm editing this video. So if I were to trim this and trim that, those get added to the trim history. And so here I'm just telling it that those silent regions that it finds should also be added to the trim history because we want to remove those silences. And it started the implementation. You can read through this if you want, but it had some bugs in the implementation. So here I'm just prompting it to show me this data down here. Actually, let me click detect silences. So this data down here, because the threshold it was giving me was just detecting everything as a silence. And then, so it fixed that and made some changes, and it still wasn't working. There was just a small bug when I tried to load the page. Duration wasn't defined in the audio waveform, and so it just needed to be imported, I guess. There wasn't anything that was really wrong with the code. It was just that missing import. And then actually it still wasn't working properly, so I just told it, here's the data I'm seeing. It's just detecting that everything is negative 100 decibels. And so for that reason it wasn't working. And then with that piece of information, it was able to finally figure out what the issue was, implemented the code to fix that issue, and then it got it working to a point where if I click detect silent regions, it would produce this. But let's now get down to the real business, to the real reason we're here. It's about time that we start connecting this transcription to the video. So what we're gonna do is generate a transcription of this video, display it here. In that transcription, we'll have word level timestamps. That means that every word will have a timestamp corresponding to that word from when that word was spoken, so the start time and the end time. And then whenever there are any big gaps in the speech, so say I were to be speaking, today we're going to, and I were to just go silent for a while, be talking about video editing, and then continue on with the sentence, that would be a segment that I would want to automatically remove. And I can do that by using the timestamp of this word when it ended and the start time of this word when it started, detect that it exceeded a certain threshold. Maybe it's 0.8 seconds, maybe 1.1, whatever. You'll be able to configure it. All right, let's get started. So all of these changes that we made in this thread here, I'm just gonna discard everything. I won't keep any of that. I'll start a new thread. That message thread I don't need, so I'll just delete it. And before I start prompting it with how to implement the transcription in this page, it would be simpler if I can get this to work separately, I think. So given a video file, extract the audio, use a speech to text model to generate that word level transcription, and then print out the gaps in the speech. So really we just needed to create a script that can do that. And then once we get that script working, then we can prompt Cursor to just implement that code logic into this page here. So let's go to Cursor to prompt it. Please generate a JavaScript file that loads a video file at the path below and passes that video file to a speech-to-text model, like Whisper. I want Whisper to return a transcript of the video with word level timestamps. And before I continue, I've worked with Whisper before, and when it's generated the transcript, sometimes even if there's a big gap between the speech, so say for example between demonstration here, the end of this sentence, and the word today, the start of the next sentence, there can be a gap of say 10 seconds. And in the word level transcription, or excuse me, in the word level timestamps, sometimes it still doesn't show where the word demonstration clearly ended and where today begins. For some reason, Whisper will include some of that silence as part of the timestamp for one of these words, either the end of this word or the beginning of the next word. I can't remember which one it does it consistently, but I think it is. It just attaches any silence to the last word that was spoken. But let's see if we run into that issue. All right, so we need to go into cursor and provide it the path. I'm just copying the path that I have here in my public folder, and it's not pasting. Okay, just had to copy the path here, and then I can paste it. And let me add another line to see if maybe there's some kind of configuration in Whisper where you can control those silent regions or control how they're detected and the separation of words. Please configure Whisper so that the word level timestamps start and end exactly around a word, and any silences in the audio are not captured in the timestamp of the words. Okay, hopefully that's good enough. And for context, let me provide it the Whisper SDK. Okay, so Whisper doesn't show anything. Maybe I have to add a new doc. I don't think I do need to. It probably just doesn't recognize it by Whisper. Whisper Python SDK. Okay, so let's see. I think probably we can provide it with the GitHub. Let me see PyPy. I'm not sure if it really matters, but I'll just provide it with the GitHub. So I'll copy that link there, and then I'll paste it here. Whisper, okay, it's recognizing it. Prefix, confirm. I'm surprised this hasn't been indexed. It probably has. Whisper indexing started. Whereas before, whenever I provided it, say the LangGraph Python SDK, that had already been indexed before I had started using it. Although April 13th, that was only 2 days ago. So maybe it was updated recently. That's why it's showing that date. But Wavesurfer, it was sometime in early April when I started using it, and it had already been indexed before. It looks like Whisper has been indexed. Maybe not. I don't know what this yellow dot means. I think it's still in progress. I'm really surprised that it's not already in its context space. Whisper, I think that's just the one that I already have. Okay, so I just have to wait for Whisper to finish indexing. I wonder if there's deepgram. Deepgram? No, that's not in there. Deepgram is another really popular speech-to-text model, and it's really good. They solved a lot of the issues with speech-to-text models. Like when you use Whisper just from the GitHub, sometimes if you submit an audio file that has lots of pauses, the transcription can error out, or not error out, but it wouldn't even tell you that it found any errors. It'll just loop a certain phrase, maybe the last phrase that was spoken before the silence. And then even if there's speech after that silence, it might not even pick that up, and the rest of the transcript is just useless because it's just looping the one phrase that it got stuck on. And when you're using a commercial speech-to-text model like Deepgram, they've solved a lot of those issues. Anyways, while that is being indexed, I'm going to go into Perplexity, and I'm going to ask it to see if anyone else has run into that issue with the word level timestamps, basically not showing any gaps in between the words. When I use the Whisper speech-to-text model by OpenAI, to transcribe an audio file, the word level timestamps that I get from the model are not very accurate. The start times of the words are usually very accurate, but the end times often include the silence that follows that word before the next word is spoken. How can I configure Whisper so that the end time of a word is set to when the word is finished being spoken and it doesn't include any silence after the word was spoken? Let's see what it says. Okay, it's generated a response. It looks like why Whisper's word end timestamps include silence. OpenAI's Whisper model provides word level timestamps, but its end times often include trailing silence after the spoken word. This occurs because Whisper was not explicitly trained for precise word boundary detection. It optimizes for transcription accuracy, not timestamp precision. The model processes audio in chunks, and its internal segmentation does not always align exactly with word boundaries, especially at the end of words. The end timestamp for a word is often set to the start time of the next word or the end of the segment, which can include silence if there's a pause before the next word. Can you configure Whisper to fix this? There's no built-in configuration in Whisper to force end times to match the exact end of spoken words and exclude following silence. The model's design and training do not support this level of precision by default. What are some solutions and workarounds? Use forced alignment post-processing. Tools like WhisperSync and WhisperX use forced alignment models to realign the transcript with the audio at a much finer granularity. These tools analyze the audio waveform and the transcript to adjust timestamps, achieving word level accuracy within tens of milliseconds, and specifically trim trailing silence from the word end times. Here's an example. WhisperSync applies forced alignment after Whisper's transcription, correcting end times to match the actual end of speech. That's awesome. So it looks like we're gonna have to look into using these libraries. Another solution is to use enhanced Whisper variants or extensions. Here's some projects that it mentions. It mentions WhisperX again and how it applies dynamic time warping or cross-attention based alignment to improve word level timestamp accuracy. Another solution is to apply voice activity detection. I don't know if I'm going to do that just because if there's already a library, WhisperSync or WhisperX, that already does it, then I'm not going to reinvent the wheel and implement this technique to detect those silences. Another solution is manual or heuristic post-processing. Again, we're not going to reinvent the wheel, so we don't need to look into these techniques. The recommended approach is for the most accurate word level timestamps with end times matching the actual end of spoken words and excluding silence, use a post-processing forced alignment tool such as WhisperSync, WhisperX, or Whisper Timestamped. Apparently WhisperSync is a commercial API and WhisperX is an open source project that uses wave to vector for forced alignment, and it works with Whisper output. And then Whisper Timestamp is also open source, and it improves end time estimation using attention-based alignment. Here's a summary table of everything we've read. The default Whisper model has low to medium precision. It doesn't exclude silences, as we already know. But these other libraries that it mentioned, like WhisperX, has high precision, does exclude silence, and it's just an extra step for post-processing. WhisperSync can do the same thing, high precision, exclude the silences, but it is a commercial API based. This might not be a bad option actually. If I can just send the audio file to an API endpoint and get the transcription, that's pretty awesome. I don't have to host a GPU server to process my audio files and get them transcribed. Because Whisper, if you're using the open source model, it is a machine learning model, and machine learning models need GPUs in order to run efficiently. It can be done with a CPU, but it's going to require a lot of memory, and it's just better to use a GPU. And using a deployed GPU is very expensive, so it might not make sense to deploy a GPU, especially if we have very little traffic on our site. It wouldn't make sense to have Whisper deployed to some server that has a GPU when most of the time that GPU isn't even being used. And there's other solutions that cloud service providers provide so that you can only use a GPU when you're getting a request, but I think for simplicity, I'll just go with WhisperSync. They'll probably have a free trial anyways. And then the other options it mentions, they're not even worth looking into. And Perplexity actually gives an example workflow if I were to use WhisperX, that open source model here that has high precision. It says, first I would transcribe the audio with Whisper, saving the segment word timestamps. And then I run WhisperX forced alignment on the output, so that word level transcription and the original audio. And then I use the adjusted timestamps from WhisperX for precise word boundaries. Here's some references that I found. So in summary, you can't configure Whisper to exclude those trailing silences from word end times. All right, so let's look into WhisperSync. Let's see if there's a free trial or free tiers. If I search WhisperSync, did I spell it wrong? WhisperSync, let's look into the resource that it used. So WhisperSync, here's just explaining the motivation behind this tool. There's a 7-day free trial. So this website looks like it's very low budget. Let's go to pricing. So under the free tier, you get 10 minutes of transcription. I guess it's better than nothing. Per month for free. And under the creator plan, it's $9 a month. You get 10 hours. That's almost $1 an hour. The pro plan gives you 100 hours. That's 80 cents an hour. And then if you scale higher, for $500, it's 60 cents an hour. So let's just assume we have this production level application, and maybe we have about 1,000 hours or like 5,000 hours, let's just say. If we assume with this pricing tier, maybe we're spending for 5,000 hours at 40 cents an hour. That's going to be $2,000. Anyways, I'm not sure if I trust this. It just looks like a very low budget website. You can see that they're using Suplo. Let me go back to Perplexity to see if it found another resource where WhisperSync was mentioned. Let me go into the sources. So I didn't find any other source where it mentions WhisperSync other than source number 6. All right, let's put that one on the back burner. Maybe we'll come back to it. I'm thinking we'll probably have to go with WhisperX. So where did it find WhisperX? Resource number 5. How can I get word level timestamps in OpenAI's Whisper? This was asked almost 3 years ago. So here they're using the Whisper model, and they've got an NVIDIA GPU. So the top answer mentions this project, and I think that was referenced in Perplexity, Whisper timestamp. Let's open that up. So Whisper timestamp has 2.4 thousand stars. It's been forked 180 times. Okay, so that looks promising. What did Perplexity say about this one? Whisper timestamp project. Whisper timestamp, medium to high precision. Exclude silences partially. Better than not at all. If the best thing that can be said about this project is that it's better than the default, it doesn't seem like there's a lot of good options. Okay, so after reading this, I'm gonna go with WhisperX. And if I open up the GitHub repo here, I actually don't need to index this GitHub repo. I was trying to index the Whisper documentation, but really I just need to provide this README file to Cursor so that it knows how to work with this library. So let me just go into the README file, and I'll just copy the raw document. I'll go into my cursor, and then I'll open up a notepad. In the bottom left here, let me pull it up. Let me see if I can pull it up so I'm not in the way. So I do have the WhisperX here README, and also the Whisper. I don't think I'm going to use it, but it's there. So now that I have this WhisperX in my notes, I can go into prompting cursor. I'm going to provide it the context of that README file, and I named it WhisperX I should have named it something else because there's two that are coming up. This one's my notes, and then this is the, I guess, the repo that was indexed on February 28th, which was roughly 2 months ago. So here's the README file, and now I can tell it, attached is the README file for a speech-to-text transcription model, WhisperX. Please install it into my current project using the latest version. Do you not use any alternatives? I need to use WhisperX specifically. And I think WhisperX, from what I remember reading, it requires Python version 3.12. Does it say? It doesn't say, but I have 3.13. So let me just add, if my Python version is not compatible with the latest version of WhisperX, please install and use the correct Python version. Once installed, please use WhisperX to generate a word level timestamp transcription of my uploaded video file. The transcription panel contains a mock transcription, and this will be replaced with the actual transcription that you generate from this library. The word level timestamp should be stored in the state of this React component, and the transcription shown by the transcription panel should only include the text and not the timestamps. You will need to create a Python backend server in order to run these libraries. Please use a fast API application for this backend server. That's just because that's what I'm familiar with. I've built lots of applications with fast API. It's really easy to learn, so if you're not familiar with it, it won't take you long to figure it out. Especially if you already have experience with Python server frameworks. And then I want to make sure that it checks that everything's working correctly. It checks that the library is installed and there aren't any issues. So I'll just add, once you're done with the implementation, start up my front end with npm start, and then start up my back end and check the logs for any errors. Okay, I think that sounds good. So this is the old prompt that I was going to use, but I'm not gonna provide it with that after the research that we just did. So I'll submit this prompt. Okay, it started generating a response, and what I realized is I actually should have provided it with some more context. For example, I mentioned the transcription panel. I should have at least given it that file, and I think maybe the video panel file would have been good too. But let's see if it finds it on its own. So it'll start by looking at the project structure to understand how to integrate the functionality. It's looking in the package JSON for the requirements, and then it's going to look at the front-end code. So it found the front-end code, and then it knows to look into the components directory, and then it finds the transcription panel in there. So that's good. I didn't need to provide it. And it's going to look into the server directory, and I had this directory already created because I ran this before recording this just to make sure that I could get it to work. But otherwise it would just run the command to create the server. It's checking for any existing video files in the project, and then it's looking at other components, including the app, the edit page, the video editor context. That's good because that's also what I would have provided it for context. It doesn't seem like you really need to provide context as long as your application is pretty small, which ours is right now. But as it gets more complex, then you would want to provide the context just so that its focus is restricted to specific files. Okay, so now that it understands my project structure, it's going to create the backend, and it's going to update the front end to use that WhisperX model. So here's it going to start creating the fast API backend server. These are all the requirements. So we're now getting into developing in Python, but don't worry, it's going to be easy to understand if you haven't worked with Python. It's good to learn it because a lot of these machine learning libraries are Python based. So it's creating the fast API application. It looks like it's still working. Let me see. Okay, so it's waiting for me to prompt it. It wants to start the server. It has this shell script. Okay, I'll just run it. It's always dangerous to run shell scripts, but I trust it. You could also configure cursor to have YOLO mode. And YOLO mode basically just executes any commands that it thinks it needs to run. It'll just execute them without waiting for you to manually run them. But I don't like to live that dangerously. All right, so it's still working. It's creating a ton of stuff. I'll go back to reviewing the top of this. I just want to make sure that I'm giving it permission to run these commands. So it's just going to change into my server directory. It's going to create an environment that's going to contain just the requirements in my requirements.txt file, because Python works differently than React and NPM. With NPM, you have your node modules folder here in the top left, and any dependency that you install in your project, they just get saved in here. But with Python, you need to create a virtual environment. Here's mine. And all of the dependencies are defining your requirements.txt file, just like they would be in the package.json. And then they're installed in this virtual environment. And then once you create that virtual environment, you have to initialize it, you have to activate it. And then once it's activated in the shell environment, then you can install your requirements with this command. So let me just run it. It looks like the implementation, it already did up here. I'll review it after. We want to make sure that it works first. Okay, so it looks like it installed everything, and now it's ready to start up my front end. So I'll run that. Oh, I guess it didn't start up the back end before. Yeah, it didn't. It just installed everything. So again, it's gonna change into my server directory, because from there, that's where I have my environment. And then it's gonna activate that environment, and then it's gonna run this ubicorn command to start up my backend server at localhost with port 8000. So I'll run that. Okay, wow. I ran into a lot of issues while trying to get this library installed, but I finally got it figured out. And the application is working. You can see here in the logs, it looks like it already transcribed the file that I submitted. And here we have the transcription. Amazing. All right, it did introduce some issues with our application. For example, I can no longer see the video on the right-hand side or the audio waveform. If I make the screen smaller, it does appear. So it is there. It looks like it's just a CSS issue. So I have several threads here where I was trying to troubleshoot this issue. What I'm gonna have it do is document everything in the README file. That way, if you have any issues that you run into while following along, you can troubleshoot with that. And then I'll also have in the prompt that I provide for generating these changes, I'll include all of the requirements that I needed to satisfy in order to get this to work. So if I go into the first thread that we started, there's too many threads for me to just explain everything that I went through and all of the changes, especially because a lot of these changes were eventually overridden. So what I'll do is prompt cursor to review all of the changes that are in staging, and then have it group all of these changes into separate commits, write out a summary for the changes for that specific commit. We'll review those changes in the code and then submit the commit message. And then after we've done that, we've reviewed all that code, then we'll continue prompting cursor so that we can solve all these UI problems. We'll identify all the problems that exist with all these changes and make sure those are fixed before we wrap this video up. Okay, so we're ready to commit all of these changes because our application is working. Well, it's sort of working. There's a few things that we need to fix, but right now we have a lot of changes that we don't want to lose track of. And since the app is sort of working right now, we'll worry about fixing those issues after we've committed all of these files. But before I commit these files, I want to make sure that the README documents for the server and the front-end application are accurate. So what I'm going to do is prompt cursor to look at all of the changes that are currently staged in the project and confirm that the documentation in the README files is updated. So I'm going to say, attached are the README files for the front end and the back end of my application. The back end of my application uses WhisperX to transcribe video files that are sent to the back end. And WhisperX requires Python version 3.9, 3.10, 3.11, or 3.12. I should have just said plus greater than or equal to. I am using Python version 3.10, and I created a virtual environment with this Python version specifically in order to get WhisperX to work correctly. can you please run the following command in order to view the git stage changes to understand the code? And let me just give it the command. The command is git diff cached cat. You pipe it to cat. And then I want to say, after it reads the code and it understands the changes, then please update the README files to reflect your understanding of the project so that someone who is trying to clone this project and initialize it doesn't have any issues. Okay, so I'm giving it the README files, and that's good enough. It's going to run the command. Okay, so it understands that the backend is new, and it's going to update the main README file. That's for the front end. It knows that we got rid of the mock transcription. Anyways, I'll just wait until it's done. Okay, so it updated the documentation. Let me just take a look to see what it looks like. So this is the front end. It saved that note about WhisperX requiring these Python versions. It initializes the front end and then sets up the back end, install requirements. So this script right here, I don't want to include it because most people aren't used to initializing projects that way. So I'm just gonna delete that one, that note from the README. Just delete that there. Take a look at the updated file. Okay, and this is the command to start up the backend. And then it even has that test file for testing the WhisperX, although I'm not sure if it's even working. It was generated by those long threads that I had between Gemini 2.5 Pro and Cloud 3.7 Sonnet, and I'm not sure if in the end this is still working, to check that the app is working, but we can edit it later. All right, everything else looks good. It didn't make any changes to the server README file. Well, I guess it did. Let me open that up. Okay, this is it. Let's take a look at what that looks like. Oh, wow, it included a lot of really thorough documentation. So everything from the beginning is pretty much what's in the front end, but then it also includes samples of the API endpoints and how do you make calls to them, and then some notes on troubleshooting issues. Okay, so I'll leave it, and then I'll stage these so that they're included. Okay, so now I'm ready for Cursor to write commits for all of these files. So instead of trying to write one commit for all of these files, I'm gonna have it group the files into separate commits, write out a commit message for each grouping, and then commit those respective files, and then do that until it's staged and committed all files into separate commits. That way it's easy to read through the commit history if anyone needs to. So I'll start it with the same prompt as before. Please run the following command in order to view my git stage changes to understand the stage changes. The command git diff cached pipe to cat. And then I want to say, then group all of the changes by separate commits. You can decide how to group them. Once you have grouped the files into separate commits, please write a commit message for each group. Stage the respective files and commit those changes with the message you wrote. And then I want to make a note about, you will need to unstage certain files. They are not included in the first commit since all of the files are currently staged. And then I will also want to remind it to look at my cursor settings. So if I go into cursor settings, I have these rules right here. These are my rules for writing a commit message, and I'm actually going to paste them in a separate file. So let me open up a note. Let me create a new note. Let me paste that in, and then we can even preview what that looks like. So this is the guide that I have in my cursor settings, in my cursor rules. So it writes clean commit messages every time. But in this case, I'm going to save it in a separate file so that I can reference it in the cursor prompt. Commit guide, enter. Okay, so going back into the cursor prompt, I'm also going to say, make sure to follow the attached guideline for writing a commit message. I don't need to provide it with any context because it's going to use the stage changes as its context along with this commit guide. So in reality, Cursor should recognize that this guide is already in the cursor rules, but Sometimes it has ignored that rule and it didn't write the commit message how I wanted it to. Okay, I think that's ready to run, so I'll run that. And let's see, in the source control, as files change, they're going to be unstaged and then staged and so on. So first it's going to look at the entire changes that I've made to all these files. So it created all these groupings. The first group is for the backend implementation, the server. The second one is for the front-end transcription features. Third is for the audio waveform enhancement. And then lastly, the CSS styling for the transcription. So it's going to run this command to unstage all of these files. Whenever you're not sure about a git command, make sure that you research it, because if I were to do a git reset hard, it would delete all of my changes. Right now with this in its current format, it's just going to unstage the files. So I'll run it. You can see that it's now listed under changes, but they're not staged. And now it's ready to add the files from group 1, which it listed here. It's going to stage these. And so you can see that here on the left, they're staged. And now it's ready to write a commit message. And so the subject of the commit message is implement WhisperX transcription server. And then it has a whole body for the commit message. And we'll review these shortly. I just want to make sure these changes are staged, or committed, I mean. Okay, so it's just going to repeat the same procedure for the rest of them. Now it's going to stage the files from group 2 and so on. Okay, so it actually created a 5th group, and that's for just the documentation update, the README files, but it didn't include the git ignore. So let me just include that, and then I'll commit amend it. So I'll include it in the most recent commit. Just save that message and close it out. So now the git ignore was also included in this group 5 commit. Now it's going to verify all the changes that have been submitted, and I'm getting an error now. It just says connection failed. Well, I know that it worked. There's nothing in my source control, so let's move on. Files have been saved to the git history, and if I do a git log one line, I can see these were the last 5 commit messages that I just sent. So these are the commits that contain my recent changes. And I'd like to be able to view all of the file changes so that I can review the code, right? The reason I did it this way first, by saving the changes to the git history, is because it's very easy to create a new branch and then visualize these changes in that new branch without having to worry about my changes disappearing. So let's say you're not familiar with how to do that, you would ask an LLM to help you. And that's what I did. I just asked DeepSeek, I'm in the main branch of my Git project, and I would like to create a separate branch where I undo the 5 most recent commits. I just want to undo the commits, but I want the file changes to still be there so that I can easily view the code changes made in these 5 commit messages. Is there another technique for doing this, or is this the best approach? And then it just tells me there's a few techniques. It looks like there's just 2 techniques, but the best one is to do a git reset soft. So first you want to create that new branch, and let me just clear this. So we'll do a git checkout -b, and then let's name this branch undo last 5. So if I do git branches, git branch, you can see I'm in a separate branch. If I were to do git log one line, we can see that our origin main, so our GitHub repo, is currently at this commit, but the branch that I just created, undo last 5, and the main one are up here, right? But now the second command, if I do this git reset soft and head for the last 5, I'll just copy that, paste it here. It's going to undo these last 5, submit that, and you can see these are all the file changes that I just saved in all of those commits. And if I were to do git log one line again, you can see that my current branch is in sync with my GitHub repo. So let me clear that. And here I have all of the changes. So now let me go into cursor again, and I'll start a new thread just because the last one had an error with the connection. And I'll just paste the part of the previous prompt that I had given it to check out the stage changes. And then I'm going to tell it, please describe all of these changes thoroughly. I'm reviewing the code and I would like to understand all of these changes. Let's submit that. And then with this response, we should be able to understand all of the changes made. So let me run that again. This is a bit redundant because this is the third time I've submitted this part of the prompt. And I might improve this technique later in the future, but for now, it works. And it reduces the number of mistakes when you give cursor a very narrow focus, right? Instead of giving this part of the prompt and then including all the other two prompts that I had given it before into one single prompt, this reduces the mistakes that cursor will make. Okay, so it finished writing the summary, and here's the summary for the server implementation. Here are the front-end changes. Looks like there was lots of front-end changes. And then the documentation changes, and then the key features that were added. All right, so let's dig into the code. Let me just make this smaller, and let's go to the top. So let's start with the first file I mentioned. It's the server/app, server app. Let's open it up. And this file is a new fast API server that provides API endpoints for the transcribing audio from video files. It uses WhisperX to generate accurate transcriptions with word level timestamps. So if we just scan it, we can see that WhisperX is imported. Here's where it's initializing that fast API application, and it's giving it the name WhisperX Transcription API. It added some middleware, has some logging with specific formatting, and this will help when we're reviewing the server logs to identify any issues or any logs and be able to identify where those logs are coming from. Here it's creating a temporary directory for uploaded files, and then here it's checking if the CUDA driver is installed, and if it is, then it can use the GPU, otherwise it's going to use CPU. And then this is the function here where we're loading the WhisperX model. So it's loading it globally so that other functions can access it. Well, actually, it's defining it up here, and then it inside of the context of the function, it's just using this global name so that it recognizes that this was defined outside of the function. The scope is outside the function. And these are some options that are required by WhisperX. You can look into the WhisperX documentation to understand what these mean, but for now we'll just take them as is, and if we need to make any changes or debug any issues with the transcription, then we'll look in here to see if what we can configure. Looks like the WhisperX model that it's using is medium. So WhisperX uses the same models that the original Whisper model uses. It's just passing in some variables to when it's loading the model, and it's all wrapped in a try except block. If just in case there are any errors, then it logs the error down here. And then this get align model, I think this is probably the part of WhisperX that gets precise word level timestamps. Anyways, we'll move on. And then it's defining some classes for the API endpoints. So this is what the request should look like, the body of the request. This is the format of each timestamp. So it's going to have the word, and then when it started and when it ended. And then the score is how confident it is that that's the correct word from the audio. And then a segment is like a phrase. So it could be multiple words, and that's what the text is here for. And that phrase is usually, since it's a few words long, then it's going to have a longer start and end time. And then here are the words in the format of individual word levels. And then the transcription response, this is how the API endpoint is going to respond. And the reason this is important, finding the request and the response in this way, and then also further defining the inputs, because here we have the segments, right? It's a list of a segment, which is defined here. And then within the segment, we have list of word levels, which are defined here. And so by writing it this way, then in our API documentation, it's gonna be easy for us to read the API documentation. So if I just pull it up, I'm gonna start the server so I can have access to the API documentation provided by Fast API. So I'm starting the server now. Okay, our application has started. So now we can go to this endpoint here where the application is running and we get a response. But we want to take a look at the documentation provided by FastAPI, and you can see here's the transcribe endpoint, and then down here for the request body, this one's just requesting or just needs a file as the input, but you can see it formats the response very nicely. Here we have the segments, and then within segments we have a list of word level. Actually, that's within the words here. So this is the word level class that we were looking at. And then if we were to look at the other endpoint, transcribe file, you can see this is what the format of the request should look like, and then the response will look like here. It's just a string, I guess. Okay, going back to the code to review the rest of the changes. Here, it's just a function to clean up the temporary file. I guess it's to remove it after it's processed. And then here, it's saving the file to disk. This is just in development, right? But if you were to deploy your server, you wouldn't want all of the files that your users are uploading to be saved into disk. You would want them to be saved in some kind of storage, whatever cloud service provider you're using. They have solutions for saving files onto there instead of saving them directly onto the server where your application is hosted. And then here's where it receives the request for the transcribe endpoint, and then the response model is assigned to the transcription response class that we defined up here. And by assigning it this way, that's how we get this nice format here in the response. And then here are the inputs to that endpoint handler. It looks like it's going to be running a background task to transcribe the audio file in the background, so that way it can respond to the client that made the request and let it know that the request was successful. In the meantime, it's going to continue processing that transcription in the background, because sometimes if the file is really long, it'll take a while before the transcription is done, right? And you don't want the client to be waiting that entire time, because the connection may time out between the client, so the browser, and the backend server. That connection usually doesn't last very long, and if it's unstable, it'll disconnect, and then you don't get a message from the server letting you know that your request was made successfully. Anyways, here it's just checking that the model has already been loaded, and if it hasn't, then it's going to load the model. And depending on which WhisperX model you use, again, we're using medium down here, but if you use a different model, it could take longer, because I think the medium model is like 1.5 gigabytes, and you don't want to load it inside of your endpoint, but we're only doing that if it hasn't already been loaded. So as soon as it receives the request at the transcribe endpoint, it's going to save that file, looking at that file, that function that we already looked at earlier. It's going to load the audio to the Whisper model, and then it'll begin the transcription. After it gets that transcription, I guess it passes into the get align model, and that gives the word level timestamps aligned so that's more precise, which is ultimately the reason we implemented WhisperX, right? Because Whisper doesn't give us very precise word level timestamps. And then this last little bit is just to format the word level timestamps so that I guess it can be saved in a specific format, and it's saved into a file path, I'm guessing. Actually, this background task is to schedule the cleanup of the created file, but this endpoint really is responding with the transcription in the original request. So we'll need to fix this later, because we don't want the client to be waiting for this response, because it can take a while. But we didn't run into that issue while we were in development, because, well, all of this is just happening within my computer, right? My front end and my back end are within the same hardware, so that's why we don't have any issues. But we'll fix this later so that it's better defined for a production app. And then here's the end of the try except block to log any errors that it finds. And then here's another endpoint for transcribing a file. And it looks like the logic is pretty much the same. It's probably just a different input that it expects a file instead of what the other one was requesting was also a file. Let me take a look at the docs. So the transcribe expects a file here in the request body, and the transcribe file, I guess you can define more stuff. I don't know, the logic looks pretty much the same, and we'll remove any redundant code later. But for now, this file looks good. I don't think there's anything that we missed. Here's the root endpoint and then the root handler. So you can see this is the response we got when we went to our server endpoint at the root. Oh, it's not running anymore, I guess, so it's not responding. Anyways, this is how it's starting up the server with this unicorn command. And then once it starts it up, that's when it loads the model. And I want to stress this again, that you want to load the model when you initialize the server instead of inside of the endpoint, because that model is a big file and you don't want to add to the delay in responding to your client because you're loading a pretty big file. And then for the server implementation, the next file that it created was the requirements, and that's just a list of my Python dependencies. This would be the equivalent of the node module, actually the package.json, where you have your dependencies listed there, right here. So that one's easy to understand. And then there's this start server shell script that I have. And this one's not super important. This is just to make sure that whenever I'm trying to start the server, I just have one command that I can run, and it'll check that the virtual environment is created. If it exists, I mean, then it'll activate it, and then it'll log this message, activated virtual environment. And if it doesn't find that virtual environment, then it's going to create it, activate it, install the requirements, and then it'll log this message, virtual environment created and packages installed. And then it'll also check for FFmpeg, because FFmpeg is required by Whisper, and I guess also WhisperX, because I mean WhisperX is using Whisper and it's building on top of it. So it makes sense that WhisperX would also require FFmpeg. And these are some variables for better performance, I guess. And finally, it's going to start up our server with this unicorn command. So you don't have to run this shell script, you can just run this command directly, but you just have to make sure that you've already activated your virtual environment. This script just makes it easy and ensures that your virtual environment is activated. And then lastly, for the server files is the test whisper file. And I actually haven't run this to see if it tests correctly, and then looked at these log messages that it has here. But it's good to know that it's there, and I'll use it later. I'll modify if I need to, but I already know that my implementation is working with, at least with the current file, right? But for now, we'll just keep this file in mind, and we'll refer to it in the future if we need to try to troubleshoot any issues with the server. Okay, so now let's review the front-end changes. We'll go into the audio waveform file, which I have open here. Okay, so the changes that it made to the audio waveform include better syncing with video playback and handle the transcription data. And these changes are improved waveform visualization with new colors and settings. I wonder why I did that. I didn't ask for that in any of the prompts. The next one is better synchronization between the waveform and video player. That's another one I didn't ask for. And then support for transcription feature to highlight words at the current time. That's pretty cool. I didn't even ask it to do that, but it is nice if that does work. So let me look into the file here in the source control so I can look at the changes that it made. So it imported these two new values from the video editor context. I guess this would be the whole transcription, and then this would be some kind of function. Let's open up that video editor context, and I want to search for that function, find word at time. So if I were to run this function, I guess this runs as the time progresses in the video, and this is what determines what's the word to be highlighted as the video is playing, because I imagine this is probably passed into whatever is keeping track of the current time in order for it to continually calculate what's the current word. And then that way, as the video is progressing, it's highlighting the words as the time is being updated. So if we go back into the audio waveform component and then search for how that function is being called, we can see it here. It's hard to see in this view, so let me change to this view here. And we can see it being called here. So it's being called within this event time update, just like we thought. So this event listener is listening for time updates on the video and then calculating the word at that specific time. And then there's a comment here. It says you can use this to highlight the current word in your UI. So I guess the logic isn't implemented because this variable isn't being used. Okay, let's see what else has changed in this file. So I made lots of changes here to when it's initializing the wave surfer. And maybe that's why we're having bugs with our application where you can't see the wave surfer anymore. The waveform, I mean. So I don't like that it made these changes, especially because I didn't prompt it to, but I've already committed these, right? We're looking at these changes as if they're still current because we're in a different branch. We're inside of the branch called undo last 5. But in the main branch, these have already been committed. So we'll have to revert some of these changes. The easiest way is probably going to be to just prompt cursor to do it. But I can see here that it also changed these event listeners on the wave surfer object. Even this event audio process and the interaction, both of them were deleted. So these are probably the changes that we're going to have to undo in order for our wave surfer to work the way it used to. But let's pretend like we don't really know what's going on here, and when we prompt cursor to fix these issues, we're just going to describe it in natural language so that it understands what the bugs are, even if we don't. Okay, I won't look too closely into this implementation just because we will undo a lot of these changes. So let's move on to the next file, and that's the transcription panel. But so far, the function here, find word at time, it seems like it's going to be a useful function so that we can highlight the words as they're being spoken. That's a pretty cool feature. I hadn't even thought to ask it that yet, and it implemented it, so that was awesome. Okay, so where were we? Let's open up the transcription panel. Here we are. Let's see what changes were made in this file. We got rid of the mock transcription. Yeah, this is the one that we would have the most changes in because before it was just the mock transcription, right? This right here, this text, and it was just simply provided as text for the UI. But now we have all kinds of logic in order to make the request to the backend to get that transcription based on the file that's been provided. And let's see, this effect, when is it running? Let me go into this view. When is this one running? Anytime the video file changes, and then it has the set transcription updater function inside. I thought I remember it continually pulling the transcription, but maybe not. What if I look into the logs of the server? Okay. Before I thought I had noticed that it was continually requesting that transcription from the backend, but apparently not. So that's good. That's one less issue that we'll have to deal with. Let's just continue reviewing this file. So all of this is just to check that the video file has been uploaded, and then it pulls the transcription as long as it gets a good response, or if it doesn't get a good response from the transcription endpoint, then it throws this error here. But otherwise, if it does, then it calls the set transcription updater function, and that's within the video editor context. So it's updating the state inside of the video editor context, and that's the end of that. And so this is happening when the video file is a blob, but when it's a path for a static file, then it runs this logic. And that's why we have the two endpoints. So as we work on this app, eventually we will just need one endpoint because all files will just be a blob, I believe. They should be a blob because our users, when they interact with the app, they'll have to go into the upload page, and then they'll upload their file from there, which gets passed into the edit page as a blob. And the reason we have this logic for handling static files is because we're currently loading a static file into this page whenever one isn't provided. And that's just so that I can refresh this page and then test it within here without having to do that extra step of uploading the file. So eventually this logic here for how to handle it when it's a static file will be removed. And so will this endpoint for transcribe file. We'll only need the transcribe endpoint. And then same check here for the response from the endpoint. If it does have an error, then it raises that error. Otherwise, it sets the transcription according to the response. That's the end of the try block. If there are any errors in the try block, it logs them. And then it sets the error state inside of this transcription panel. And that's the only effect hook that we have. And then for the rendering, we have, if there's an error, then render this message here. Please check the console for more details. If the transcription is loading, it says generating transcription with WhisperX. This may take a few minutes. So I'm guessing that happens when I click generate. There we go. So that's the message that is appearing while transcription is loading. And if neither of these have been activated, so it's not loading and there's no error, but there's also no transcription available because I haven't clicked that button. So this is the state that we get. And so this is the HTML that gets returned. And if none of those three have been returned, then we present the actual transcription data. So I'll just click generate. We've already seen what that looks like, but this is the formatting it uses to create that UI where we see the transcription. Okay, our transcription has finished loading and here it is. We can scroll within this window and it doesn't look super nice. I mean, we can fix some of the CSS to make it more presentable, especially because it's currently hiding the video, but this is pretty good for now. All right, let's move on to the next component in the front end changes, and that's the video editor context. So what has changed? Let me pull up that file, video editor context. So we can see that it extended this component with a new state and functions for the transcription. It added the transcription and transcription loading state. We can see that up here. Let me pull up this view instead. So we can see it added these, and then it added the generate transcription method to trigger transcription requests. Let's see, when is this being called? I guess it's being provided to the children. So let me search it in the code base, and it's being called by the edit page here. It's being loaded, and then here it's being called when a user clicks on the transcribe button, which is being rendered in the edit page, then it calls that generate transcription. And that generate transcription logic is down here. And here we have the same logic that we had before, where it's checking the file URL. If it's a blob, then it sends it to the transcribe endpoint, and if it's a path, then it sends it to the transcribe file endpoint. Hadn't we already seen this elsewhere? Where did we see it? In the transcription panel? Yeah. So we have redundant logic. This one inside of the transcription panel is running inside of this effect hook, which is executed automatically anytime the video file changes. Whereas the one inside the video editor context runs when this function is executed, which is executed by the edit page right here inside of this onClick event handler for the button click. So I don't think we need this button, because when the user lands in our page, we'll want the transcription to be automatically loaded. And that's what this effect hook is doing inside of the transcription panel. And so we don't need this same logic to run on that button. But again, since I've already committed these changes, I can't make a change here. I'll have to wait until I go back into the main branch, and then I can make the changes and write a new commit. I thought it was going to be a good idea to commit all of the files that I had up to the point where Cursor had generated a semi-working app, but maybe that wasn't such a good idea, because now as I'm reviewing the code, I can't make any changes. Anyways, it was worth a shot. Let's continue reviewing. The last thing that was added in the video editor context was this find word at. It's a utility to locate words at specific timestamps. That's one we already looked at. And then the inside of the edit page, it updated with a generate transcription button and transcription handling logic. That's the logic that we just looked at for this onClick event. And then the component CSS, it just added some new styling for the transcription panel. Okay, documentation changes. It added some troubleshooting information. Let's pull up the documentation, Readme. Let's look at it in preview mode. And it says it added troubleshooting information related to GPU memory issues with using WhisperX. Where is that? Okay, I don't see that in this one. Maybe it's inside the server README. I don't think it makes sense to have two README files, so I'm just gonna consolidate them into one a little bit later. Okay, I found it. It's inside the server README, and then here's the troubleshooting section, and then GPU memory issues down here if you need to refer to it. And then it mentions the Python version requirements up here, and then it includes FFmpeg installation instructions. Let's see. The installation instructions for FFmpeg can also be found in the Whisper documentation, because Whisper is the one that's using FFmpeg. And so here's the documentation. I haven't tried following it from here, but it looks the same. You brew install FFmpeg using any of these methods depending on what operating system you're using. Okay, that's it for the documentation. And so the key features that were added, we already know what those are. It uses WhisperX to provide accurate transcriptions with word level timestamps. The word level timestamps are synchronized between the text and audio. Although after reviewing the code, there was no logic to actually show this synchronization. We're not doing anything once we find the word at a specific time, but it is synchronized, I guess. Next feature is the transcription integration, basically just saying that it added this transcription into the video editor page. It has some error handling for any errors as a result of the transcription. And then it has some loading states and clear error messages that we already saw earlier. So with all these changes, it transforms the video editor from a basic tool to one with advanced transcription capabilities, making it more useful for tasks like captioning, subtitling, or content analysis. Well said. Okay, now that we're done reviewing the code, we can get rid of all these changes that we made and go back into the main branch where all of our changes have been committed, and then continue working from there. So let me just delete these changes by doing a git reset hard. That'll just wipe all of this. I could submit this command, or I could just click up here, discard all changes, and that deletes all of my changes in my git history. Okay, now that that's done, we can go ahead and move back into our main branch. And we actually have all of these files. Most of them are from the virtual environment or the PyCache. And that's because, actually they're all from the virtual environment. That's because I need to git ignore the name of my virtual environment. I had previously named it this, and then when I renamed it, I didn't make sure to include the new name of my environment. So now that I've included it in my git ignore, these should all disappear. Yep, okay, they're gone. And just to double check where we are, let's look at the branch. Okay, we're on the main branch. And then we no longer need this branch here. So let me copy its name and then do a git branch -d for delete. And then I can paste the name of the branch, and now I can double check that there isn't a branch with that name. Okay, now we only have the main branch and we're in it. If I do a git log one line, I can see where we're currently at. And all of the changes that we've made up to this point have been committed. So now we need to start clearing up some of those errors that were introduced by our chats with Cursor. So first thing is to make sure that we stage this change in the git ignore file. And then based on these changes over here on the right that Cursor had made, we can start to undo some of those changes, right? So let's go into, where was it that we said? I think it was the edit page where we had some logic that we didn't need. And that's this transcription button. But I don't actually want to do the coding myself or editing. So I'm gonna prompt Cursor to do it. But first I need to start up my front end, and then let me start up the back end. So let me change to the server directory, and I can start up my server with this script here. What it does is starts up my virtual environment, and then it starts up the server. Okay, it looks like the server is done initializing it. It did load the WhisperX model successfully, that's good. And then if I were to navigate to the app, let me refresh. Okay, so the first thing that we want to fix is when we land on this page, we're assuming that to get to this point, the user has uploaded a file, and we want to be able to present the transcription automatically without them having to click on generate transcription. So let me go into cursor, start a new thread, and tell it that, oh wait, I can see that it's transcribing the audio. So it is doing it automatically. And as we saw earlier, that's happening inside of the transcription panel, inside of this effect hook right here. So I guess we will see, oh, there it is. So it did load automatically. Okay, so we'll need to provide that as context. And then we'll need to tell it the edit page is also part of the, not the CSS, the JavaScript file. It's part of the context because my prompt is going to say the edit page has a button called generate transcription. And when the user clicks on it, there's a function that it calls named handle transcribe click. This function calls the generate transcription function from the video editor context. So let me provide the video editor context as well. This logic is not needed because our transcription panel already requests a transcription for the video automatically. And then I want to talk to it about this fetch transcription function with the double logic where it checks if the URL is a blob or if it's a file path. Additionally, the fetch transcription function inside of the transcription panel effect hook has logic for handling video file URLs if they're blobs or file paths. Why do we need both of these? And then I want to look for where's that logic that loads the default file. It's inside the edit page, and here it is, load default video. Okay, so let me just ask it, is this because the edit page loads a default video when it doesn't find one in local storage? Okay, I wanted to ask that just to make sure I understood it correctly. So let me submit that and let's see what it says. Okay, so it responded, and before we look at the response, let's see what it looks like in the app. So if I refresh, okay, so immediately I can see that it's generating transcription and it's letting me know that it's going to take a little while. Okay, that's good. That's exactly what we wanted for it to load that transcription automatically. So let's see the explanation. Okay, so it recognizes that there is a duplication because the transcription panel already automatically fetched the transcription when the video file changes, and the generate transcription button in the edit page that is called when the button is clicked, and it is identical to what was already in the transcription panel. So this is redundant. And then it says the default video loading in the edit page shouldn't require separate transcription logic. So it's gonna eliminate the duplication by first removing the generate transcription button from the edit page and then consolidating all the transcription logic into one place. Looks like it's going to be inside of the video editor context. Let's take a look. Okay, so nothing has changed in that file. And then the transcription panel is going to use the logic that's inside of the context. So let's go into the transcription panel. We can see all of these changes that it made. So it got rid of the set transcription updater function because I guess it's no longer going to be called within the transcription panel. And it also got rid of the transcription. No, it didn't. It's right here. But it did import the generate transcription function. This was the function that the edit page was previously calling. If we remember here, when the button was clicked, it was calling this function. And in this function, which is in the video editor context right here, here's the logic for transcribing the audio based on whether it's a blob or a file path. So now we don't need the logic inside the transcription panel because we can just call this generate transcription function. And then it just updated the message so that it's no longer asking the user to click transcribe. So all of these changes do look good. Let me just accept all of them. And I'll stage the transcription panel. The edit page, I can also stage because it got rid of the button. So let's stage that one as well. And let's continue reading what cursor has to say. Okay, so as we just learned, the transcription process is now as follows. When a video is loaded, either from local storage or the default video, which is just temporary while we're testing, the video file state in the context is updated. This triggers the use effect inside of the transcription panel. That's this effect right here. Because the video file is updated, it triggers this effect, and so now it's going to call the generate transcription. That's what step 3 is about. Transcription panel calls the context generate transcription function. And in the context, so let's go into the video editor context. The context handles the transcription process based on the video type, blob or file path. And this solution is cleaner, more maintainable, and avoids potential race conditions or confusing behavior from having 2 separate transcription mechanisms. Okay, good. That sounds good. Did it answer the question on why we need to handle blobs or file paths? I don't think it did. And then where did this default video file come from? Let's search default video. Maybe that was created before. Let me delete it. Let me load this page again and see if it's created again. Okay, so while that's loading and we're waiting to see if it creates that default video file, let's commit these changes. Let me get rid of this context. And instead of prompting it with the same prompt that I always used to use, which is, please summarize these changes into a git commit message. I can submit it and it'll do it right, and then I can just copy paste. Or I can go into my notepad and then I can open up this this commit message file, which if we look at it, it's just the guideline for creating a commit message. And I'm going to update this file. At the top is going to be the prompt. Please summarize these changes into a git commit message using the guideline below. And please commit these changes using all of the files in staging. Okay, so now this can be my prompt. Whenever I want it to generate a commit message and make the commit, I can just use this. So I'll open up the cursor chat, and all I have to do is do an @commit message. I don't have to say anything else because basically I'm providing this as a prompt. Let's look at what we have in staging. Everything looks good. Let's submit it. Okay, so here's the message that it wrote. That looks good, so let me approve it. I thought that would approve it and then it would continue, but it didn't. So I guess I have to prompt it again and say, that looks good, please continue. So I'll prompt it again. Okay, that didn't work like I thought it would. I was hoping that it would run the command to commit the staged files. So I'll work on that. But that is how you're supposed to be able to use it. Okay, so I actually got it to work. I just had to update the prompt. If we take a look at my commit message document, we can see that the prompt is, run the following command in order to view my get stage changes to understand the stage changes. And the command is get diff with the flag cached, and then it's piped over to cat. Then please summarize these changes into a git commit message using the guide below. I've tried telling it to just reference the guide that's in the cursor settings. So if I open up the cursor settings, I have this down here. It's the same one that I provided it here, but it didn't work. So I had to specifically copy and paste it into here. And then finally commit these changes with git commit -m and then the message, where message, it's not showing up. It's not showing up in this preview, but I have it here, where message is the commit message you write. And then here are the rules. Write commit messages according to the following guidelines. The format of the commit message is, and so on. And then if I prompt inside of a new chat thread, if I just do the @ symbol and then paste in the name of the file, then it goes on to execute these commands. So first it checks the staged file. And remember, it's only going to look at whatever was already in staging. If it hasn't been staged, it's not going to look at that. And then based on what it sees in staging, it writes the message. You can see it does follow the guide here with a subject line and then the body. And then it just gives me a summary of what it did. So it does work. One thing you can probably also add is a note about the current thread. So I'll add it actually, and I'll see if it works in the future. Let me just put it in parentheses. And my note is, you may want to refer to the conversation in this thread to help you understand the stage changes. And then that way, whenever you run this prompt, it might use the thread that you're currently in. So say I was back in the thread where I ran the prompt to make all of these changes, right? Where it changed the transcription panel and the edit page and so on. If I were to run it there, then it might use that conversation to get a better understanding, and then its git commit message will be slightly better. All right, enough of that. What else do we need to fix? Let's go into our app. Okay, continuing with troubleshooting the errors that we've introduced into our app. I can see that default video file that we were waiting for has been created. So we'll have to figure out where that's coming from. And then I can also see that the transcription is just looping. I mean, it's continually being requested. So I'll have to see what's going on there. But the first log does tell me that in the app file, it says save uploaded file to, and then this is the path to default video. So let me search for that sentence, saved, uploaded. Okay, and I found it here. So this transcribe endpoint is being requested. And here, save upload file. Let's see, where's this function? Okay, so it's uploading the file to disk and then returning the file path. Why is that necessary? How is it used? Okay, we get the file path and then we provide it to Whisper. Let me actually cancel my server so it stops continually transcribing. Really, the issue is coming from the front end because it's the front end that's sending this request. So we'll eventually get to that, but I want to know why it saves the file as default video. That's probably going to be an easy fix. So here's where it gets the name. So it gets the name here. That's what default video is. We can change it to, and then we can replace. Okay, I updated this line so that instead of just saving it to a path with default video as the file name with no extension, I've updated it so that it has an extension. And then now I want to look into what's the issue with the front end continually sending that request. So that'll be done in the transcription panel. So this is the effect hook in the transcription panel that generates the transcription. It calls this function that's inside the video editor context. And the only reason it would run, the only reason this effect hook would run is if this video file were being updated. So let's see, maybe this video file is being set inside this function. The function to set that video file is this one here, right? Yeah, this is the updater function. So is that updater function being called within? No, it's not being called within the generate transcription function. All right, let's see. Let's go back into my app. I refresh the page and add edit. And then let's look at the logs. So this is the last log that my server wrote once it finished initializing. And then when I refresh the front end, this is where the logs begin from then. So it saved the uploaded file to the disk, right? And it saved it to this path. We can see that the file is here. And it is the file, the default file. I just wanted to take a look. And what's happened? So it saved that file to disk, and then it's loading the audio file. It's transcribing it. Once it transcribes, it aligns the transcription, and then it generates a log for each word. And this is the timestamp for each word. So for the first word is all, and then it shows the start and end time and the score. So where's that coming from within my app? It should be the transcribe handler. Okay, so it's within this for loop, and it's only logging the first word in each segment as shown here. And after it's done, it returns the response, and in the background it's cleaning up that file. So it's removing that temporary file, but then it restarts again. So that's what we need to ask cursor. Okay, I stopped the front end from running and I restarted the back end to see if it would start transcribing, just in case there was anything in the back end that was triggering it, because I can't see why the front end would cause it to trigger multiple times. But there's nothing in the back end alone that's causing it to transcribe that file. So I'm going to ask cursor why this is happening, and it's happening in the transcription panel. So I'm going to give it that as the context, and then the edit page because it's the parent of the transcription panel. And then I'm also going to give it the backend server, which is app.py. And I'm going to ask, when I load the edit page, it loads the transcription panel. And inside the transcription panel, there's an effect hook to generate the transcription. When I look at the logs for the backend server, I can see that the transcription is being generated multiple times, meaning that the generate transcription function is being called repeatedly. Why is this happening? Okay, I give it the context. Let me just submit that. Okay, and it responds and it says that the transcription is being generated multiple times because the generate transcription function in my effect hook dependency array is likely being recreated on each render of the parent component. So we can see that the generate transcription here is a dependency in my effect hook, and it's being recreated, I guess, every time the video editor context is rendering. And that does make sense because I remember looking at the function and it wasn't being memoized, but the code change that it implemented uses a callback, so that wraps the function as a callback, so that as long as nothing inside the function has changed, then there's no reason for the function itself to have changed. And for that reason, it doesn't need to be recreated, because since our transcription panel was using it as a dependency, if it was being recreated, that means that this effect hook was seeing the function as like something new, like an updated state. So it says to fix this issue, wrap the generate transcription function in the use callback, and it was able to search my code base to find the function within the video editor context, even though I didn't provide it as a context file. So now if I were to start up my front end, npm start, that loads my application and I can see that it's working on generating the transcription, and we'll just wait for that to finish. If I look at the logs of the backend, I can see that it loaded the audio file and it's begun transcribing it. Let me just continue reading through the cursor response. It says, okay, so here's it showing us that all it did inside the video editor context was import the use callback hook from React, and then it wrapped our generate transcription function in that callback. And so that this function shouldn't change. Let me make it bigger. This function won't change as long as this video file hasn't changed. So it only has that one dependency. And as long as the video file doesn't change, this whole function doesn't need to be redefined because it'll stay the same. So let me just accept this change. And then the dependency is the only other thing that it changed in this file. And then it updated the transcription model. Looks like it did add a few things here. And it added some more checks. So before it was just checking that the file is loaded, and this time it's not going to generate the transcription if the transcription is already loading or the transcription already exists and we have the segments, the timestamps for the transcription. And then it adds these two other variables as dependencies. So I'll accept those changes, and that's it. It was a simple fix. If I go back into the app, I can see that the transcription has finally shown up because it's no longer continually looping. And then that also solves the issue with the file being saved. And that's because when the file was being sent to the server, we had this code at the top of the endpoint handler where it was saving that file to a path. And then once it was done generating the transcription, then it would clean up that file. But since we were having this endpoint being looped continually because of the front end was calling it continuously, then that file never really disappeared. So let's see if my commit message or guideline for creating a commit message is going to work. Remember, the prompt that I have here in my notepad is to run the following command in order to see what files are staged, and then to create a commit message based on those changes, and then push them or commit those changes. So I'm going to stage everything. Actually, I didn't double check what it changed in the app.py file. Oh, nothing. Cursor didn't change anything. This was the change I had made, and everything else Cursor did. So now that we have that prompt that I can just use instead of having to type it in every time, I'm going to just provide that as context, commit message, and I don't have to say anything else. I can just submit this and it should be able to write a commit message and proceed to call the tool to commit it. So hit submit. It's thinking and knows it needs to summarize the changes. So it's going to look at the changes that are staged. It always fails the first time, but eventually does recover. And here is the commit message. And the main subject is prevent multiple transcription API calls. Excellent. This affects the transcription and it's a fix, which is accurate. And then it has bullet points. Fixed issue where transcription was being generated multiple times when loading the edit page. Changes include memoized generate transcription function with use callback, added condition checks to prevent duplicate API calls, updated dependency arrays to properly handle cache function. And that's excellent. That's a really good commit. So I will accept that, and it's committed my changes. Awesome. All because I have this one instruction here in this notepad file. That's going to make things a lot easier to commit from now on. I wonder if it used the thread history. We can look at the thought process, but it's not clear in here in its thinking if it used the history of this thread where I prompted it to make that fix. Well, it's working, and that's all we wanted. All right, let's look for what other issues we have in the front-end app. I just reloaded it, so we're waiting for that transcription. In the meantime, we can see that the audio waveform has disappeared. And I remember that there were a ton of changes that were made to that audio waveform. So in order to be able to visualize what changes we made inside this component so that we can revert them, I'm going to go into the terminal and I'm gonna hit Command K so that I can prompt Cursor down here to generate a command for me. And I'm going to prompt it with, I made some changes to the audio waveform file that I would like to undo. These file changes were made since commit ID, and then I need to provide it with a commit ID. So I'm going to take a look at my Git history to see when that was. So since this commit ID, this was the last time we synced up with GitHub. So I paste that ID in, and then I'll just say, can you please revert the changes? And before I hit execute, let me make sure that that command can be written here. So I'll hit submit, and it generated this git command. It says git checkout and then the commit ID minus minus and then the path to that file. There's nothing in my source control right now, so I'll run it and then I can see all the changes that it undid. Okay, so this is everything that we've changed within the audio waveform, and that makes it easy to be able to figure out what we need to leave discarded, or revert back, I should say. So what we had done before was imported the transcription and the find word at time from the video editor context. I think that part is probably okay to leave. So I'll revert this so that I couldn't do it because it's staged. So let me unstage it. Let me revert. So that's okay. I'm going to leave that there. I don't think that broke anything. This change here where it was no longer assigning the WaveSurfer instance to the WaveSurfer ref, I think that probably made like a breaking change. Let's go back into our application and there we go. It's there along with our transcription. Awesome. So I'll leave this as is, but I want to make sure that the other functionality still works as expected. So before it had deleted this logic here, I don't know why it would have done that when this logic was working well for us. And then what else? Let's see. Where does it use find word at time? In here, in this time update. Oh yeah, this time update event listener we probably want to keep. And it's being defined once WaveSurfer is ready. So let me just copy this part here, sync waveform with video time update, and then I'll paste it here. And I actually realized that this WaveSurfer ref.current was later assigned down here at the bottom, right? WaveSurfer ref.current to the WaveSurfer instance. So that shouldn't actually have made a difference. What did change was it was trying to get the duration from the WaveSurfer instance here by calling this method. I don't know if that's an actual method that exists on the WaveSurfer object, but it was working before, so I'll just continue using the video reference instead of the WaveSurfer duration. And I just realized there's some extra brackets here. Not brackets, they're curly braces. So this shouldn't end yet because I still want to define these functions down here. And then it's not WaveSurfer, it is WaveSurfer ref.current. And this ready should end down here. Okay, that looks good. We actually want to keep these down here as well. So let me remove that and put it down here. Still not happy, so let's see. This one ends down there, that's correct, but these need to be shifted over. If you don't understand what's going on, I'm just putting all of these event handlers within the ready event. Wait a second, I don't want to do that. These are WaveSurfer ref. I want them in their own. It should only be this one here, the time update, that's within the onReady event. Looks like there's still an issue with my syntax. Where could it be? Down here? Okay, now that I collapsed everything, I can see that this one here needs to be moved down. So if I collapse this one, nope. You know what? Let me just prompt cursor. Where's the syntax issue with my audio waveform? Audio waveform. Instead of asking it where is it, I'm just gonna ask, please fix the syntax issue in my audio waveform component. Okay, it generated the fix, and let's see. Okay, great. It closed the loop here for this onReady event. So I'll accept that one. And then it closed the function up here, initialize WaveSurfer. Let me go into this view. Okay, I think that should work. If we reload the front end and, all right, it looks good. All right, let's continue reviewing all of the changes that we want to revert inside the audio waveform. So I had previously tried to implement the seeking event. Again, it must be using old documentation because the current documentation shows that it's triggering a interaction event instead. And then where's this video reference being used? Okay, I see. Okay, let's keep that change. So I'll accept that. Okay, I think that's all that we needed to change in the audio waveform to get it to work again. So if I click here, it does seek to 29 seconds. If I click here, it's 41, okay. And then can I trim regions still? If I click trim, it does create trim regions. What if, let's see, I want to be able to see if these events are being logged. It does look like region created, and then updated when I shift it. Yep. Okay, so all that seems to be working like normal. The transcription's there. The view of the video, we should probably fix that next. But first, let's stage the audio waveform, and then now we can prompt cursor to fix the view on the edit page. You know what? Let's provide it a lot of context. I'm going to provide it with the pages, everything in pages, everything in components, and also everything in styles. And I'm going to say, my application is working great. It's working as expected, but I have CSS styling all over my files. I need the CSS to be consolidated into the files in my styles directory. Additionally, I need to be able to see the video panel on the right hand side of the transcription panel. And right now the transcription panel is taking up the entire width of the top row, and the video panel cannot be scrolled into view. I don't want to have to scroll the video panel into view, and I would like both the transcription panel and the video panel to be visible when I first load my application. If the user makes the screen width more narrow, then the video panel can move under the transcription panel, but only then. Okay, let's submit it. Let's see what it does. Okay, it finished responding. It took a while. It actually made a lot of changes, and it thought for a long time, and it changed a lot of files. I won't read about the specific changes that it implemented, but I even started up my application to see if it was working without issues. And here's the application. This is what it was looking like before, so it's looking great. If I make this window smaller, what happens to the video? So eventually it does move to the bottom. There's still some styling we need to fix, but it's looking a lot better. Okay, so I do want to commit these changes. So let me unstage the audio waveform first. I'll stage everything, but I'll make sure to unstage the audio waveform because I only want to commit the CSS changes. And then I'm going to prompt it again, commit message, send it that prompt, and let it create a commit message for these changes. And here are all the changes. It's just CSS that it changed, so I don't really care too much about what it says. And just like that, those files are now committed. And I'll do it again for the audio waveform. Send that same prompt again, commit message, send. Okay, didn't understand. So let me just start over from a new thread, and let me send it that prompt again. At commit_message. Okay, it finished looking at the state changes, and then it has this commit message. It refactored the audio. It should say audio waveform. In fact, I'll just add that. And the subject is improve waveform sync with video. Replace seeking event with interaction event handler. Update waveform colors to match application theme. Fix sync mechanism between video and waveform. Remove inline styling in favor of CSS classes. Add responsive property for better UI scaling. Great. I like it. It's committed those, and now our application is coming together. All right, that wraps it up for this video. Our application is working as we expect. We start out with a loading page, and then once the speech-to-text model transcribes the video, we get this transcription over here on the left. Everything is working as it was before. I can seek the video, I can create regions and trim them, and I can resume playing the video from where I last seeked it to. In the next videos, we're going to work on syncing the transcription with the playtime of the video. So as it's playing the video, it's highlighting over here on the left-hand side the corresponding words that are being spoken at that time. Kind of like having a captions effect. We're also going to add a detect silence button so that we can cut out any regions where there's silence. For example, this region right here. We use the transcription and the word level timestamps in order to find these silences so that we can automatically remove them from the video. There's a lot of things that we can do with this app, and I'm really excited to continue building it. Hopefully you guys learned something along this journey with me. If you're finding this content valuable, please give it a like and subscribe to see more like it. Hope to see you in the next one.